I am holding NASA's latest report in my hand, but before we descend into the details of this revelation, I need you to participate in a global calibration of sorts. Go to the comments section right now, type in the name of your city, and tell me honestly, have you noticed anything strange in the night sky recently? Objects that defy orbital mechanics, lights that pulse with a rhythm that feels deliberate. NASA has quietly opened the civilian observation network, but they aren't telling you the true reason why. What I am about to share is going to fundamentally dismantle your understanding of humanity as status in this galaxy. NASA just dropped a major update on the interstellar visitor we've all been tracking, 3I Atlas. And if there's one word that sums up the entire report, it is unsettled. This object is not stable, it's not calming down, and it is certainly not behaving in a way that our scientists can predict. It is officially in an unsettled state. And if you have been following the journey of this traveler from beyond our solar system, and you want to know exactly what happens if it continues to defy the laws of cometary physics, make sure you are subscribed and stick around until the very end. Today's update quietly confirms that 3I Atlas isn't reaching the end of its dramatic display. It is right in the thick of it. The first major red flag in this latest data didn't come from some stunning high-definition photo. Instead, it surfaced in the one place most people never look, the fit quality of the orbital calculations. Every single day, observatories and spacecraft beam back new position measurements, and these are essentially tiny dots in the sky that pinpoint exactly where 3I Atlas was at a specific moment in time. Scientists take those coordinates, feed them into an orbit solver, and ask a simple question. Does the model we built yesterday still accurately predict where it is today? This time, the answer was a definitive no when the mission team applied yesterday as parameters using the same assumptions about non-gravitational forces and gas-driven outgassing. The predicted path and the actual path didn't just miss by a small margin. They missed in a very specific, deliberate pattern. All the new data points were sitting slightly off to one side of the track. They had just spent weeks refining. This isn't just random background noise. This is behavior. To fix the discrepancy, they had to manually tweak the non-gravitational acceleration yet again. This is essentially the tiny engine effect caused by gas jets erupting from the nucleus and pushing it like a rocket. The updated model shows that this push has tilted in a brand new direction and remains far stronger than any standard comet model should allow at this distance from the Sun. In short, the trajectory is unsettled because the physical forces driving it are completely unsettled. While the orbital mechanics team was wrestling with the math, the imaging specialists were busy stacking and sharpening the latest deep exposure photographs to see how the object's atmosphere and tail have evolved. The pictures tell the exact same story, just in a visual language. Last week, the inner coma, the glowing cloud around the center, looked stretched out but relatively coherent. It had one main bar of brightness and a clear, predictable axis. But in today's images, and that internal structure has twisted again. And the brightest part of the coma is no longer aligned with that old bar. It has rotated, almost as if the spine inside the glow was grabbed and wrenched several degrees to the side. One side of the inner coma has thickened significantly, while the other has grown thin and ragged. Even further out, the tail shows a faint new kink, a subtle bend that wasn't there before, indicating that the stream of dust is now tracking a completely new direction of thrust coming off the nucleus. None of this points to a total catastrophe yet, but every pixel is whispering that nothing here has settled. Then we have the issue of rotation. To understand how 3I Atlas is spinning, NASA tracks how its brightness fluctuates over the course of several hours. A stable, solid object usually gives you a clean, repeating light curve with the same peaks and timing in every cycle. That is not what we are seeing today, and when the team overlaid the newest measurements on top of last week's rotation period, the peaks were a mess. Some cycles peaked higher, some lower, and the timing shifted just enough that a single steady rotation period couldn't explain the pattern. To get the data to make sense, they had to assume the rotation period itself is drifting and that the amplitude of the spin is changing from one rotation to the next. In plain English, the comet isn't just speeding up or slowing down, it is wobbling. Sometimes a larger area of the surface faces the sun, sometimes less. The active regions are moving in and out of the shadows in an irregular way, resulting in a brightness pattern that refuses to find a rhythm. If you line up these three major pieces of evidence, the shifting orbit, the twisted coma, and the irregular rotation, you get a clear picture of what unsettled means for 3I Atlas. And the obvious question is, what is actually happening deep inside this thing? One theory that fits all the data is that the nucleus is being pulled in three different directions at once. Thermally, it is still struggling to adjust to the massive amount of heat it absorbed when it was closer to the sun. The outer layers have already blown off, and now deeper, more stubborn pockets of ice are finally catching the heat at different depths and along different fracture networks. Dynamically, its spin is being shoved around by those erratic gas jets. Every vent that is even slightly off-center applies a torque. And over thousands of rotations, those tiny pushes add up, tilting the axis and changing which parts of the object get cooked by the sun next. Structurally, all of this is happening inside a body that was never a solid rock to begin with. To make it look like 3I Atlas is finally calming down. The brightness might drop, the tail might look a bit cleaner, and the orbit might hold for a few iterations, but then a deeper pocket of gas vents, a new crack reaches the surface, or the spin axis wobbles a few degrees, and everything shifts again. That is where we are right now. Not in the middle of a massive explosion, but not in the comfort of a quiet fade-out either. We are in the unsettled zone. There is another, even more subtle clue buried in the latest spectral data, and the breakdown of the light by wavelength, compared to earlier in the journey, the ratio of gas emission to dust reflection near the nucleus has shifted once again. Certain chemical lines associated with deep-seated volatiles are still very prominent. The inner region of the comet actually shows a different color balance than the outer halo, which suggests that fresh and new material from deep inside the nucleus is still being tapped. It's not just recycling the same surface dust over and over. Every time this happens, it doesn't just add gas to the cloud, it forces the interior to rearrange itself. Pressure pockets empty, internal voids form, and the overlying crust might sag or collapse. Stress lines are moving, and if these new patterns found a stable equilibrium, we would see it in the data as a stable spin and a predictable trajectory. The fact that today's update required even more corrections is NASA's way of telling us that this equilibrium is nowhere in sight. So where does this story go from here? In the best case scenario, 3I Atlas is just going through the last noisy phase of its evolution. The remaining pockets of gas will vent out, the wobble will eventually damp down, and the jets will weaken until it finally leaves our solar system as a scarred but intact interstellar comet. In the more worrying scenario, this unsettled behavior is a warning sign that the internal stress is reaching a breaking point. Each new vent and each tweak in the spin could be pushing the structure closer to its absolute limit. We have seen comets from our own solar system take both paths. Some survived the chaotic pass around the sun and stabilized, while others stayed unsettled until the day the update wasn't about shifting data, but about the fact that the nucleus had simply vanished. Right now, 3I Atlas is still officially one solid object. There are no confirmed fragments and no clear debris stream yet, just a massive amount of motion under the hood. But today's log is a significant turning point. The numbers, the shapes, and the spin are all refusing to calm down. They are evolving in a way that is anything but simple. Think about the gravity of this for a moment. We are watching an object from beyond our stars, something that has traveled through the void for an untold amount of time, undergoing changes we have never witnessed. This isn't like tracking a familiar comet we've seen for decades. This is genuinely uncharted territory. The way 3I Atlas is behaving tells us something profound. Interstellar objects don't necessarily play by our rules. Their composition could be radically different. Their structural integrity might be unlike anything we've studied up close. And the way it responds to our sun, as heat is providing us with the first real clues about the conditions in the distant star system it originated from, every measurement, every slight deviation, and every unexpected twist in its tail is a data point we have never had access to before. Now, scientists are essentially writing the textbook on interstellar comets in real time. The models being built today will define our understanding of these visitors for generations. But what makes this so fascinating is that this unsettled nature isn't just a hurdle for researchers, it is information. Each wobble and each adjustment to the trajectory tells us about the internal mass distribution. A perfectly symmetrical sphere wouldn't wobble like this, proving that 3I Atlas is anything but uniform. The irregular jets reveal the geology of the object, showing us that it has layers and veins of different compositions buried deep within. And the spectral data is perhaps the most intriguing part of all. Those deep volatiles are materials that were buried and protected for eons, preserved through the long journey between the stars for those materials to still be there. This object had to survive, being ejected from its home system, and endure the radiation of interstellar space without being sterilized. And now it is releasing those preserved samples right where we can study them. Every gas molecule escaping from 3I Atlas right now contains atoms that were last part of a planetary system around a completely different star. The carbon, the nitrogen, and the oxygen all tell a story of chemistry that happened light years away. This refusal to settle down suggests that 3 Atlas might be far more fragile than it appears. Comets from our neck of the woods are often quite tough because they've survived many passes around the sun, developed protective crusts. But this visitor is a first-timer. Whatever protection it had in its original environment might not be suited for our sun's specific radiation and heat. It's like someone from a frozen climate being suddenly dropped into the middle of a desert. The adaptation is messy and happening in real time. The fact that NASA has to keep revising its models isn't a failure. It's a massive success of their observation methods. They're catching these transitions as they happen. The word unsettled is perfectly chosen. It describes a system in flux, a system transitioning between states. And in science, transitions are often where the most incredible discoveries are made. Imagine being one of the scientists watching this data come in every morning. You've spent your life studying these things in theory, and now you have live data from a real interstellar traveler. It would be both thrilling and nerve-wracking because you truly don't know if tomorrow's update will show stability or a dramatic break. Comparing this to comets that have shattered isn't being alarmist, it's being realistic. We know there is a line between stressed but holding and broken. And 3I Atlas hasn't crossed it yet, but it is definitely operating in the zone where that line exists. We don't have enough data yet to predict which way this will go. We don't have enough examples of interstellar comets under this kind of stress. So we watch, we measure, and we wait. The beauty of modern astronomy is that we can witness this in near real time. We don't just get before and after snapshots. We get to see the entire process play out step by step. Every report helps narrow down what is actually possible, ruling out some theories and strengthening others. This is science in its purest, messiest form. If you want to see whether the next update finally says 3 Atlas is stabilizing or if the unsettled phase has escalated into something much bigger, make sure you stay tuned. Stay curious, and I will see you in the next update.